from this study. And we had a lot of research questions. Again, if you go into the papers, you'll see the full set of research questions. But some of the questions I'm going to try and address in this study are cue recognition and response, the basic engineering assumption in all engineering analysis that people do for high-rise building evacuation. They simply have response times, occupant response times of 0 to 2 minutes. Is that realistic based on what we've seen in the World Trade Center? So we want to address that sort of issue. What other factors affect the response of people as well? We want to look at fatigue. There's been much talked about fatigue and the health issues and obesity issues. How did that actually impact the evacuation of the World Trade Center? For the most part, in engineering analysis, the assumption is that fatigue is ignored or treated in a very, very crude way. And we wanted to find out what impact did fatigue have in this particular evacuation. Travel speed on stairs. Historic data relating to stair speeds. The question is, engineers are using this data from the 60s and 70s. Is it appropriate to use in today's world? Again, if you look at an earlier study that my research group did for the Office of the Deputy Prime Minister, the BDAG project, Building Disaster Assessment Group, we came up with an analysis based on printed accounts of survivors, and we came up in 2004 with the figure that the average travel speed on the stairs was 0.2 metres per second. That's very slow. Why was it that slow? Lots of people had made opinions as to why it was slow. Obesity, fatigue, all these things. Why was it so slow? And that's one of the things we wanted to look at in our particular study. And NIST also came up with the same figure, a very similar figure as to why the travel speeds were slow, but didn't actually come up with why the speeds were so slow. So we wanted to investigate that, and we wanted to look at the impact of risk. Risk is a very little explored subject in the fire literature. We wanted to see how risk perception influenced people's evacuation behaviour. Other questions that I'm not going to have time to go through in detail here are conditions during egress. All engineering assumptions in engineering calculations that people evacuate in clean conditions. Well, did they in the World Trade Center? And if they didn't, how did that affect the evacuation of the World Trade Center? Merging flows and deference behaviour. Engineers do not have a clear understanding of how floor and stair flows merge, have no idea actually, and yet we have all these computer models that predict what they're doing and hand calculations that predict what's going on, and we don't really understand the merging process. So we wanted to look at issues about merging, and then group formation and group dynamics. Engineering assumption, again, in all calculations that I'm aware of in engineering evacuation analysis, is that occupants evacuate as individuals. From our earlier study, the BDAG study, we showed that in the World Trade Center, people evacuated in groups, and groups could be quite large. And so this will have an impact on the overall evacuation behaviour. So there's some of the questions, and the first set of questions we're going to try and address in this presentation. Just to give you an overview of the data we've got, we have something like 271 people we interviewed from the World Trade Center, 254 evacuated from floors 1 to 110. 51% of our participants are from WTC 1, and this presentation is going to focus on our findings in WTC 1. 61% of our study are males, 39% are females. In WTC 1 we had about 64% males, and in WTC 2 about 59% males. As you saw in the earlier studies that were presented, the mean age of our study group in WTC 1 was 46 years of age. This is similar to the other two studies. For WTC 2 it was 42.5. The ranges of people, the ages that we interviewed were between 22 and 68. An interesting statistic we found from our study was that 68% of the entire population were either in the overweight or obese category. And here we're using BMI, body mass index, to determine people's BMI. Also, if you look at WTC1 in detail, 63% of WTC1 population was overweight or obese, and 64% of the population were considered to be not physically active. And this is based on the NHS definition of activity, physical activity, where you do 30 minutes of moderate exercise 5 days a week. 64% of the population were not physically active, and 63% were obese, overweight or obese. If you look at our study, the data, we split the building into three regions, from 1 to 30, floors 1 to 30, floors 31 to 60, 61 to 100, and most of our sample turned out to come out of the upper third of the building. 42% of our study in WTC1 comes from the upper third, and 57% of WTC2 comes from the upper third. Why do we have more in WTC2? Well, because they started to evacuate before the building was impacted, so more people got out from above the later impact floors. Okay, I want to start talking about several of these factors. I want to talk about fatigue and stoppages during the World Trade Center WTC1 evacuation. The nature of the stoppages is quite important because it addresses issues associated with fatigue and also conditions on the stairs. We want to know, did people stop and why did they stop? Another thing is that the stoppages also impacts the average travel speed. So if there are lots of stoppages, that could explain why the travel speed was so low. From our study, we could extract data from 124 people from WTC1 for which we have some stoppage analysis. 86% of our sample stopped at least once in their descent. If you look at the sample, 18.5% stopped only once. So the majority of people stopped multiple times during the descent. And this little table here shows you the frequency of stoppages. A very high level, 35% of our sample stopped an unknown multiple number of times. They couldn't tell us how many times they stopped. If you look at the reason for the stoppages, and this is quite interesting, 43% of the sample stopped, 43% of the stoppages that were reported were caused by congestion. And they were reported by 58% of the population. And that was by far the largest factor. Congestion, congestion, congestion. This caused the stoppages, most of the stoppages in the World Trade Center. 17% of the stoppages were caused by descending people, so the wounded that were being taken down, and 16% of the stoppages were caused by firefighters going up. Actually, a very small percentage of the stoppages were caused by ascending or descending firefighters going up or disabled people going down, injured people going down. Only 8% of the sample reported stopping because they needed to rest. Only 8%, a very, very small proportion. It's a 110-storey building with all these obese people, all these overweight people, all of these people who don't take regular exercise. Only 8% reported stopping because they needed to rest. And environmental conditions, 7% of the stoppages were caused by environmental conditions. For example, smoke on the stairs, water on the stairs, and these sorts of things. Over 90% of stoppages were caused by reasons other than fatigue. Okay? That's a really important finding, I think. Over 90% of the stoppages were caused by reasons other than fatigue.